Hello everyone, welcome to the science period. So today will be the last part of our lesson, chemical and physical change. So we said that physical change do not alter the identity of the substance while the chemical change produce for us a new substance with new properties. Now, did you try to ask yourself what happened to mass during the physical or chemical change? Let's take a look here. Now, if we try to freeze 5 milliliters of water, it will give us ice. Now, if we let the ice melt, we will have also 5 milliliter of liquid water. What can you observe of this? You will observe that the mass of water didn't change. So also if we try to evaporate the 5 milliliters of water, it will change into water vapor. Okay, leave the water vapor to cool again, it will give you 5 milliliter of liquid water. And it will be the same in most of physical change. So most of physical changes are reversible. So the mass here is conserved. Now, what about a chemical change? What will happen to the mass if we mix vinegar and baking soda? So let's watch a video to know more about this.
Hey everybody, it's Mr. C, and today we're going to change the way you look at science with this simple science experiment. It's science time. It's science time. We're talking chemical changes today, and we're going to need some vinegar, baking soda, a balloon, a funnel, and also a bottle. First things first, grab your balloon, stretch it out a little bit, pop it on top of that funnel, and then take 2 hefty scoops of baking soda, shake it in. Perfect. Set that funnel aside. And what we're going to do in a second is we're going to actually attach this to this bottle. We're also going to grab some vinegar. And pour some vinegar into our container. So what we have is vinegar and baking soda. And when we mix these two things together, something happens. So pay close attention. We're going to twist this. Oh, that's awesome. So the balloon is blowing up. Woo! The balloon is blowing up. Oh, that is the best it's ever done for me. We're having a chemical reaction, and inside of this, we have something that feels like air. But it's not just any air, it's actually carbon dioxide. The chemical reaction with the baking soda and vinegar produces carbon dioxide. Carbon dioxide is a gas, and therefore rises and fills up the balloon. If I didn't have the balloon attached to this, we wouldn't be able to see what happened, because this gas is invisible to our eyes. Try this at home. It's super sciencey and super fun. Plus, you can keep doing it over and over, and afterwards, you got yourself a little balloon to start celebrating. That was awesome. Did you see that? Let's try that again.
No, we don't want to try that again. Enough. So, as you saw in the video, vinegar and baking soda are combined. They undergo a chemical change or chemical reaction, and they will produce for us invisible carbon dioxide. What happened here that we have a new substance with the new properties, but with the same mass. So the mass of the carbon dioxide is the same of the mass of vinegar and baking soda. Okay, now let's watch another video to know more about mass during the chemical or physical change.
Even the most dedicated scientist needs a break, right? And in my world, break time means settling down with a nice, cool drink. Whoa, I left a glass full of water here a while ago, and look at it now. It's only half full. Half full. I'm an optimist. But what happened to the rest of the matter? The water, that is, that was in this glass. It looks like it went away. But can that happen? Does matter ever just go away? You already know a lot about matter, like how it can change between different states, like solids, liquids, and gases. You also know that matter can be part of mixtures called solutions. And in solutions, the particles that make up matter become equally distributed in a container, like the sugar and water molecules in our picnic sweet tea. And even though we didn't know it then, that sugar went through what's called a physical change. A physical change is a change in the shape or form of matter. Physical changes do not form a new substance, and they can usually be undone. Like how we were able to separate the sugar from the tea when we heated the tea so that the water evaporated. You also know that matter can go through chemical changes, changes that occur when the particles that make up two or more substances are rearranged to form a new substance. Like, say pancakes or cupcakes or shortcake. I like cake is what I'm saying here. The matter in wet cake batter turns into a new substance, fluffy, yummy cake. There are clues that a chemical change is occurring, like the production of gas bubbles and that delicious smell. And like all chemical changes, we can't undo that change. The process by which chemical change occurs is called a chemical reaction. Scientists, being organized types, give special names to the substances involved in a chemical reaction. The reactants are things that react. They're what get changed during the chemical reaction. And the new substance that's made? That's the product. In our chemical change, the ingredients of the cake contained the reactants, and the cake was one of the products. So, matter can change. But what matter can't do is just appear or vanish. And since all matter has mass, this means that mass can't appear or vanish either. Scientists have been experimenting with this idea for hundreds of years. Lots of experiments have provided evidence of what we call the conservation of mass. The conservation of mass is the scientific rule that says the mass, or the amount of matter in an object, is never made and never lost. So, what about the water from my glass? Well, it didn't just disappear. As the water evaporated, its molecules became mixed in with the air molecules, so it went through a physical change. It's still there, but we just can't see it anymore. Let's try making a solution like we did on our picnic. Say you mix 5 grams of sugar into 10 grams of water. Remember that grams are the unit of mass. Then you stir your mixture until the sugar looks like it disappears. We started with 15 grams of materials, the 5 grams of sugar and the 10 grams of water. And when you weigh the new solution, sure enough, you'll get 15 grams. There was no change in the amount of mass that you have, even though we don't see the sugar anymore. The sugar didn't vanish, it just went through a physical change. It dissolved. But if you could gather up all the dissolved parts of sugar and weigh them together, they'd still equal the 5 grams that you put in. And we'd find the same thing if we measured the mass of the water in my glass. If we measured the mass of water that's left in my half-full glass, and we were also able to catch all of the water molecules that escaped into the air and weighed them, together they would weigh the same amount as the water in my glass when it was full. Conservation of mass.
Okay. In the end, law of conservation of mass means matter is never created or destroyed in chemical and physical change. Mass transformed into different substances. So guys, open your book on page 42. So we need to highlight and we need to solve question number 13. What is the law of conservation of mass? So it states that in chemical and physical change, mass do not created or destroyed, but only transformed into different substances. And here's the answer, and you can write it with your own words. And this is what I needed to highlight in page 42. And in page 43, you need to highlight this. And let's go to solve question number 14 and question number 15. So question number 14, how is the physical change in the robot reversible, and how can you tell that the change follows the law of conservation of mass? It's reversible by that we can bring the parts back to their places, so we will have the previous shape of the robot and the same mass. So mass can be created or destroyed, and physical change it's only transform in different forms. So here the answer if you want it. So here in question number 15, what would you observe about the mass in the flask if you did not put the balloon on the top, and why? So I will observe that the flask mass will decrease. Why? That's because the result of the chemical reaction, or the carbon dioxide gas, will move away because the balloon catch it. But if we don't have a balloon, it will not catch the carbon dioxide gas. So for sure the mass of the flask will decrease. So here's the answer if you want it. So that was all we had for our lesson about chemical and physical chains. So I hope you enjoyed, guys, and see you later.